I think it's important that everybody get to know each other, whether this is an online class or it's a blended course. Uh, Students will be doing verbal introductions in the on-ground class. For this class, it's very likely, and when I say it's very likely, I mean you will be making your first participation post to introduce yourself, to say why you're in this course, and just to give some general information about yourself. This will be, like I said, the first forum post, first participation forum post, and I think it's important that everybody get to know each other, which is why I'm doing this. We're all in this together, and this should be a very interesting class. Thank you. On this slide, we're going to outline what is expected from Chapter 1. We're going to discuss why networks are important, basic network components, network types, network layers, which we're going to be focusing on quite a bit in future chapters, network standards, and finally trends. Thank you. Why are networks important? There is lots and lots of data being passed around by many different types of devices these days. And modern organizations, and modern devices for that matter, rely on the efficient transmission of data. Networks enable distributed systems, real-time communication, e-commerce or electronic commerce. Social media continues to be a big thing, as well as the web and its increasing functionality and use in today's society. So for the online students, I'd like you to take a few seconds and think about all the different products and devices that now rely on networks. So for example, I recently had to buy a new washing machine, and some of the washing machines have like remote start features now, which absolutely is unnecessary to me, but I can control my washing machine from my phone now. So it's increased the scope of networking and networks and devices using networks is increasing every day. Thank you. On this slide, we'll discuss data communications. Data communications are the movement of computer information from one point to another by means of electrical or optical transmission systems. This is a very general term. It really just means to transfer data from one point to another through a electrical communication means. So if there's a wire and you're transmitting data, that's data communication. Telecommunication is a slightly broader term, and it involves the transmission of voice and video. That can be graphics or images, and many different audio formats, as well as data and it usually implies a longer distance. So telecommunications is specifically focused on the transmission of voice and video, but it is also considered data communications. Usually telecommunications require a much greater resources and much more efficient networks. Thank you. In a network, there are usually three basic components. They are the client, the server, and the circuit. A client is a user device to access network and receive data from the server. Some examples of the client would include desktops, laptops, tablets, and cell phones. These are any kind of device that are basically used by everyday individuals. That's how I would look at it. At a work site, a non-IT person would be a client user. However, an IT person may also be a client themselves. A server is any device that really has the word server after it. It is a device that stores and transmits data to the client. Examples include web servers, mail servers, database servers, application servers, and file servers. These are usually IT level servers. They're stored in a computer room. They're often on a SAN. We'll get into that more later, but I wanted you to have an idea. A circuit is a pathway or connection between the client and the server. This includes the actual physical Ethernet wires or fiber optic cables, wireless communication, and what have you. They are the actual connectors that link the client and the server together. So think about the physical wiring and the connections that go from one machine to the other, and that would represent the circuit as part of the basic network components. Thank you. Now we're going to look at a very simple LAN setup which has the basic network components. Usually you have a router that connects different LANs or other networks together. It could also link the internet together. There's the switch, which handles and manages communication between the file server and the individual client computers. So the file servers, as far as being part of the basic network components, the file servers are the servers, and the laptops and client computers would represent the client. All of the communication in between, in other words, the cables, the switch, and the other cables, that's all part of the circuit in this picture. So keep that in mind. This is a very quick diagram. We are going to go into all of these different components in much more detail at a later time. Thank you. Now let's take a look at networks in terms of geographic scope. So there's different types based on the size of the scope of the network. Let's start at the bottom. Wide area networks cover the largest geographic scope, and it often is composed of leased circuits, and it may span hundreds of thousands of miles. So let's think about that, leased circuits. Why are they leased? Because otherwise, the companies trying to control the wide area networks would have to own all of the land between one point and another. So let's say you have a facility in California and you have a facility in New York. Without leasing circuits, you would have to own the land from point A at New York to point B, California. So that's absolutely ridiculous, and that's why we lease circuits. Backbone networks are high-speed networks connecting other networks together. They may span several hundred feet to several miles. An example of a backbone network I can think of is the connections between the various buildings here at Albertus Magnus. So we have the academic center, we have the student center, we have the library. Those buildings are all tied together by a backbone or a backbone network. Now conversely, the local area network covers a small, clearly defined area. It might be a single floor work area, or it might even be a building. I like to look at these areas based on functional units. They don't necessarily do that here at Albertus. In other words, pretty much everything on the first floor at Aquinas Hall is one local area network, but it could be subdivided based on business department. When a LAN uses wireless circuits, they are called WLANs or wireless local area networks. So keep that in mind as well. We do have several WLANs here, or wireless LANs at Albertus, and that's about all I'm going to cover for this slide. Thanks. This slide here provides an excellent example of concepts discussed in previous slides. In the upper left, we see a small LAN as being used as the records building example at McClellan Air Force Base. With the router, this is tied into the backbone network at McClellan Air Force Base. Some of the nodes might include the main gate, the records building, the flight building, hangars, and so on. So from that, we can tie it to the wide area network, which is other various Air Force facilities in Washington, in Texas, in Massachusetts, and so on. So all this Air Force based technology and all this information and data is passed on a wide area network to the various large locations within the country. It's all tied together through the backbone network at McClellan Air Force Base, and at the localized level, the LAN is the records building in this example. So before going any further, I'd like you to try and use a bank where you work at, or maybe a restaurant chain where you work at, or that you know of if you don't have any examples like that. And think of how you can isolate it to the LAN, to its backbone network, and to a wide area network, because the examples that we could use here are endless. But this picture provides a good diagram as to how LANs are connected with WANs through backbone networks. And that's an important concept. Thank you. In this slide, we'll discuss the differences between an intranet and an extranet. So I'll start with the extranet. A network that uses the internet technologies to share information between organizations. Open only to those invited users outside the organization. Accessible through the internet. Example, suppliers and customers accessing the inventory information over the company extranet. So let's use that one as an example here. As it says in the bullet number 2, accessible through the internet. So let's look at Amazon.com. This is a good example of an extranet, although it does use internet connectivity without any specification between the actual end users and the servers at Amazon themselves. However, many of the communications between Amazon and their suppliers are confined to an extranet. Now let's discuss the intranet. I work with the intranet here at Albertus quite often. We have a lot of test servers and a lot of test applications that we don't necessarily want everybody to see. We don't want them to see the websites that we're developing as we're developing them. We want people to see a finished product that looks good. So our development is done in an intranet environment where the information and the data, the display, and the content is restricted to only certain people in a certain area to see. So let's go over the bullet points for an intranet. It is a network, often a LAN, that uses internet technologies to share information within an organization. It's open only to those inside the organization. So an example is employees accessing budgets, calendars, and payroll information, and that would be isolated. So that's how I look at it. An intranet is often isolated, and as we'll probably learn later in later chapters, there's specific IP ranges that are often dedicated to intranets. Thank you. This slide will be discussing network models. The two primary network models discussed in the chapter are the Open Systems Interconnection Reference Manual, or the OSI model, or the Internet model, which has also been referred to as the TCP/IP model. So in practice, we follow the Internet model, and as we discuss the OSI model, I'll explain why we might think that way and why we consider the Internet model more. However, understanding of either one of these models will make troubleshooting your network and data communications issues much, much easier. And these models are very, very simple, and a lot of people think that the memorization of these models is simply work. And I don't agree with that. I think that whether you follow the Internet model or the Open Systems model, applying the concepts will help you troubleshoot problems, and it can save you hours worth of difficulty, even if some of the steps you take seem repetitive and monotonous. So in practice, the Internet model won. Me, myself, I use some sort of a hybrid model that I've created that's something between the Internet model and the OSI model. So I'll go through this in detail, and we will understand the differences and how they work and how useful they are. Thank you. All right, so now we're going to discuss the network models in some detail here. Beginning with the OSI model, since it is recognized it is required for many certifications and exams. I know Cisco requires the OSI model to be well known during its certification process. So starting at the top, we have the application layer. This application layer is really the browser. It's a putty session. It's a tool that you would use to get data from the internet. It's the application. Microsoft Internet Explorer, Firefox, Google Chrome, Safari, so on. Those would be examples of data communication application layer. The presentation layer we can think of as the operating system and the environment. That could be a Linux operating system using X Windows. This could be Microsoft Windows 7. This could be Microsoft Windows 8. It could be Mac OS 10. That is the presentation layer. It's the operating system and the environment which the application will operate under. Then a session layer exists. A session layer is the actual communication channel that gets created between one server and a client, or two servers, or two peers. That represents the session, and the session is the connection that is made between two computers. Now we look at the transport layer, and oftentimes the transport layer and the network layer can be tied together. The transport layer really is the connection type. It is the TCP/IP piece. So usually the problems that you would encounter would not exist in the transport layer because it's an established standard, and usually that doesn't make the problem. It's been a defined standard for a long time, whether it be the transport be HTTP, whether it be HTTPS. Usually the error is not with the transport because it's already clearly defined. Next we have the network layer. This consists of the network. It's the DNS, the domain name server, it's the Active Directory server, it's the components that make up the network, it's definitely the DHCP services which define IPs for the computers on the network. So that's a spot right there. Usually networks are tied together through routers, as we've previously discussed. So the data link layer. Now this would be the hub layer, which we're not going to use that word hub, or the switch layer. So that is the actual switching where the connection is made from the network to the actual PC itself. So think of the data link layer as the switch layer. The physical layer actually consists of the physical RJ45 connectors and the Ethernet wire that plugs one computer into the machine. If you have a hardwired connection at your house to your computer, that phone jack looking plug, that is the physical layer. So the internet model really kind of combines some of these layers that it feels are redundant. For example, the transport layer and the network layer, they kind of tie that together a little bit. And that's what I do too, because like I said, you don't really have too many issues in this area here. And the data link layer and the physical layer, those are highly connected as well. I mean, on Windows 7 or 8, if I look down at the icon in the lower right part of the screen in the sys tray, I know whether I have internet access or not, and I know if I have a network connection. So the internet model takes a lot of these concepts and ties them together. So understand how this works, understand what the difference is between looking at your issues from the bottom up or the top down, and think of how you troubleshoot a problem. Think about, let's pretend that you have a connection that works and you can bring up Google through Internet Explorer, but then you try to do it again through Google Chrome and it doesn't work there. So think about where that problem would exist in the OSI model, and there might be a forum post on that. Thank you very much. Now we're going to talk about different types of network modeling and network models. First term we're going to discuss is the term protocol. This defines the language of the transmission. It specifies the rules, functionality, and messages for communications at a particular layer. Some protocols that may exist at, say, the application layer would be HTTP, there's the SMTP, there's several others, there's FTP. These are protocols that exist at the application layer and are considered application protocols. At the transport layer, for example, you have TCP and UDP. At the network layer, you pretty much have the IP protocol. And at the data link layer, you have different switching protocols. And at the physical layer, you're going to have a number of de jure standard protocols as well. We're going to go through those on another slide. Actually, I believe it's the next slide where you'll see a little breakdown of what protocols exist at what layer. So for the online students, I'd like you to be able to take a look at this, and I'd like you to evaluate the different protocols and get an idea as to what they are and where they are. You'll probably recognize a lot of the protocols that exist at the application layer, and you might even recognize some of the protocols at the transport layer as well. So don't worry if you don't understand these different protocols yet, just kind of understand where they are. We're definitely going to be going through these in class. Now we're going to also discuss the term PDU, or Protocol Data Unit. This contains specific layer messaging and information necessary for a message to be transmitted through a network. Every layer you're at adds a PDU, and PDUs act as nested envelopes. In the link below, which I suggest you follow, it does a really, really good job of explaining protocols, why they came to exist, how PDUs are created and how they work. I think it does a really good job, and I would recommend that you go through these slides and go through the presentation at the link below. Very good explanation. There's going to be, at the bottom of the presentation, it's going to go into some of the Wireshark install stuff. If you're brave and want to install Wireshark, I would highly recommend it. It's definitely not necessary at this point. However, we will be using Wireshark and technologies like it throughout this class. So don't worry about learning the Wireshark stuff yet. You will be learning it later on, but if you'd like to try and get ahead, that would be great. And then we're going to talk about encapsulation. This is also explained very well in this slide, but it basically involves the concept of taking the different envelopes from the different PDUs at the different layers and levels, and how it's going to nest these envelopes inside one another. And that's the concept of encapsulation. As you'll learn, there's benefits and there's disadvantages to encapsulation. So don't worry if you don't understand this. Throughout the course, we're going to make this clear, but understand that encapsulation is going to play a big part here. So these terms are important. We'll be going through them throughout the class. We'll be discussing the variations of the OSI model throughout this class as well. So make sure you understand this stuff now. And if not, I can assist if necessary. Thank you. Next, we'll discuss some common network standards and what layer they exist in. So, in the application layer, many of these may seem familiar to you. There's the Hypertext Transfer Protocol. There's the Hypertext Markup Language. There's the MPEG and H323. Those are audio-video formats. There's the Send Mail Transfer Protocol. There's the IMAP protocol and the POP protocol involving email. As in the transport layer and network layer, we've often said that sometimes they're considered part of the same layer. When you hear of TCP/IP, those are the different protocols within each layer, and these days they've actually combined that together in the naming when it's referenced. So understand that that does involve two different standards, though: the TCP standard protocol and the IP protocol. And they're used very, very much together these days. In the data link layer, there's the Ethernet, there's the frame relay, and the T1 standards. And in the physical layer, they have the RS-232, which is the serial communication standard and cable. And the Ethernet wire itself is Cat5 cable, or Category 5. And then there's the stuff with the modem as well, which I'm not going to go into because modems are kind of going away. Thank you. In this slide, we're going to look at the different protocols and how they're encapsulated throughout the layers. So let's say you're going to make an HTTP request to, let's say, www.google.com. So in the request, you have all kinds of information there, such as what type of browser you're using, what address you're looking to go to. You might ask whether it's secure or not. All that information is packed into what's called the request. That's an HTTP request. And that request is encapsulated within the HTTP message. Obviously, we're using the internet model here as well, since there are only 5 layers being referenced. Next, we'll look at the transport layer. Here, we see that the HTTP request is encapsulated within the TCP message. And at the network layer, we see that the IP protocol has also been encapsulated within the TCP message and the HTTP message. And at the data link layer, we also get the Ethernet protocol. And then we would also have a physical layer protocol. It's usually going to be 802 dot something in that regard, or in that respect, I mean. So the different names that these types of requests get throughout the different layers are packet in the application layer, segment with the transport layer. So there's a TCP segment. There's an HTTP packet. Networks transfer packets, and information coming from switches and data link layers are set at a frame, and that frame rate is established at the time of communication. We'll go into that a little bit later as well. But this diagram is meant to show you how messages are encapsulated within each other. So think of these as envelopes within envelopes within envelopes, and eventually they all get opened. So hopefully that makes sense to you. Again, if you have any questions, let me know. Thank you. This slide will be discussing the advantages and the disadvantages of layers. Let's discuss the advantages first. Networking functionality is modular, and the hardware and software at any layer can be easily substituted. For example, if you have a problem with your physical hardwired switches, it can be substituted at the physical layer for a wireless at any time. So the physical layer can be swapped out. Different hardware can be placed in as switches. There's a lot of differences and a lot of substitutions that can be made, making it flexible. As I discussed earlier, troubleshooting one layer at a time makes things much easier. And that's a very important concept. To me, that's the most important concept. Application developers need to only worry about the application layer in their programs. This is an interesting concept. So when you're writing a program, if you want to retrieve information, and you really have to write your simple program, your simple call to whatever you're looking for. And if there's a problem with it, the application developer only has control over his application and what he's trying to do, he or she. So that's important to understand, that the modularity makes it easier for developers. Now let's discuss the disadvantages. Encapsulation and decapsulation at every layer requires processing time. When we looked at our Gmail headers, those headers can be very large or very small. And at every single hop for every network along the way, those can grow and shrink, and that requires processing time. And it also increases overhead. So those are the disadvantages. Pretty much the OSI model is pretty well followed. Like I said, it's not something that people think about too often, but it does exist there, and a lot of people substitute the internet model concept for it.
just because it's more simple. So thank you very much.
Let's discuss de jure standards and de facto standards. I try and mention de jure standards, and I try and throw this verbiage into a lot of my presentations because it's important, and it's also very simple. So, de jure standards are formalized by an industry or governing body, and de facto standards are widely accepted but have never been formalized. When you're doing development or doing your work, it's best to follow de jure standards if possible. I think that it has a greater chance of a successful outcome just because it is formalized versus not formalized. So, like I said, I try to throw this verbiage into my presentation, so look for me using these words throughout the class. Thank you.
Here we are going to talk about trends. One of the main trends being the bring your own device trend. There's a huge demand for employers and colleges to connect their personal information, smartphone, tablets, Xboxes, what have you, to their organization's network. Every year I see students come up to the IT department with their Xboxes, and we help them connect them to the network here at Albertus. Employees are able to connect through the wireless here to access email and what have you while on campus. And that presents security challenges because when you bring your own device, you don't know what's on that device. They could have malicious software on it. Then there's the issue of who's responsible for it. So they do present a lot of challenges. It's a relatively new trend within the last few years, but these questions need to be understood and considered. And I know right now that many colleges are focusing on security, and they're actually creating security teams to work through issues that come up involving new trends and new concerns. Training of people is hugely important, and those people are internal staff as well as external users, and I think everybody's on the same page there. But the BYOD concept is coming into play. Thank you.
So I'm going to combine this slide with the next slide. These are just some other trends that I've kind of mentioned that are kind of going on right now in the worlds of data communication. And like I said, this all seems to be increasing. So that's it for the first chapter here. This chapter, I realized, was a very hands-off chapter. I know that you all want to do some hands-on work, and we're going to definitely get to that. Like I said, we're going to be focusing on doing a lot of reading of data and messages being sent across the web in an attempt to understand and actually see it. I'm a very visual person. I like to see things, and then when I read it, it makes complete sense. That's what I'm hoping to do in this class as well. So, again, I know this chapter was kind of slow, but it will pick up. Thank you.